Greetings to all lovers of artificial intelligence, and for all those interested in its wonders. I hope that you are well. We are pleased to announce the launch of a new video series on an exhilarating journey, in which we delve into the world of artificial intelligence. Our goal is to conduct a dialogue with the AI on various topics to find out its opinion by answering questions directed to it. Our inaugural installment will delve into the captivating world of electronic circuits, and our first topic in a series of segments will be on the Joule Thief circuit. But before we begin this unusual adventure, allow us to address those who may not be familiar with the Joule Thief circuit, its components, and installation procedures. There are many videos that comprehensively explain this circuit. Our goal here is to engage in a captivating conversation with the AI about this particular circle. On the video screen, you will find the question posed to the AI and eagerly await its insightful answers. I'm filled with anticipation to hear her unique opinions and perspectives as she answers these interesting questions. Without further ado, let's begin our exploration, delving into a captivating discussion surrounding the Joule Thief circle. First of all, we welcome you.
Thank you for the warm welcome.
Let's start with the first question. Can you introduce us to the Joule Thief circle from your point of view?
Of course, the Joule Thief circuit is a fascinating and innovative electronic circuit, known for its capability to amplify a low-voltage power source to a level sufficient to power devices that typically require higher voltage. This circuit employs a clever arrangement of components, including an inductor, a transistor, a feedback winding, and a diode, working in tandem to efficiently boost the voltage from a nearly depleted power source, such as a nearly drained battery. By harnessing the principles of electromagnetic induction and energy transformation, the Joule Thief serves as a practical solution for prolonging the life of batteries and extracting power from seemingly unusable energy reservoirs. Its simple yet ingenious design has found applications in various fields, including electronics, low-power lighting, and energy harvesting systems, making it an indispensable tool for powering devices in resource-constrained situations.
Great. Can you explain to us how the Joule Thief circuit works?
Sure. Here's an explanation of how the Joule Thief circuit works. The Joule Thief circuit works by using an inductor, a capacitor, and a diode to step up the voltage of a DC power source. When the input voltage is applied to the Joule Thief circuit, the inductor in the circuit starts to store energy from the input voltage. During this stage, the diode is reverse biased, which means it does not conduct any current. After the inductor has stored enough energy, the input voltage is removed, and the energy stored in the inductor must go somewhere. The inductor starts to discharge its stored energy through the diode and into the output capacitor, which raises the output voltage. As the inductor discharges its energy, the current in the circuit flows through the diode and into the output capacitor. At the same time, the diode becomes forward biased and starts to conduct current. This allows the output capacitor to charge up and increase the output voltage. This charging and discharging cycle of the inductor continues, creating a high-frequency AC waveform that is smoothed out by the output capacitor, resulting in a steady DC voltage output. In summary, the Joule Thief circuit works by using an inductor, a capacitor, and a diode to create a high-frequency AC waveform that is smoothed out to produce a higher DC voltage output than the input voltage. It's a simple and efficient way to step up the voltage of a DC power source.
Thank you. That was incredibly insightful. Now, let's explore the next question. What components are needed to build a Joule Thief circuit?
Sure. Here's an explanation of what components are needed to build a Joule Thief circuit. To build a Joule Thief circuit, you will need a few basic components. These include An inductor. This is typically a coil of wire that stores energy when a current flows through it. It's a critical component of the Joule Thief circuit, as it helps to step up the voltage of the input source. A capacitor. This is an electronic component that stores electrical energy in an electric field. In the Joule Thief circuit, it helps to smooth out the output voltage by filtering out the high-frequency AC waveform produced by the circuit. A diode. This is a semiconductor device that allows current to flow in only one direction. In the Joule Thief circuit, it's used to prevent the output voltage from flowing back into the input source, which would cause the circuit to malfunction. A power source. This is typically a battery or a DC power supply that provides the input voltage to the Joule Thief circuit. Other components that may be needed include resistors, capacitors, and transistors, depending on the specific design of the circuit. Overall, the Joule Thief circuit is a relatively simple circuit that can be built with just a few basic components. However, it's important to choose high-quality components and to follow the circuit design carefully to ensure that the circuit works as intended.
Your knowledge of this topic is commendable. Let's proceed to the next question. Can a Joule Thief circuit be used with different types of batteries?
Yes. A Joule Thief circuit can be used with different types of batteries. The circuit is designed to work with a wide range of input voltages, which means it can be used with batteries of different chemistries and capacities. However, it's important to note that the efficiency of the circuit may vary depending on the type of battery used. Some batteries may not provide the same output voltage or current as others, which can affect the performance of the Joule Thief circuit. Therefore, it's recommended to choose a battery that is compatible with the circuit's specifications, and that can provide the necessary input voltage and current for the circuit to operate efficiently.
Incredibly helpful. Now, for our next exploration. What measures can be taken to optimize the performance of a Joule Thief circuit?
It would be my pleasure to answer your question. There are several ways to optimize the performance of a Joule Thief circuit, including choosing the right components. The choice of components can have a big impact on the performance of the circuit. It's important to select components that are of high quality and that meet the specifications of the circuit. Tuning the circuit. Adjusting the values of certain components, such as the inductor or resistor, can help to optimize the circuit's performance. This can be done through trial and error or by using a circuit simulator. Using the right battery. As mentioned earlier, using a battery that is compatible with the circuit's specifications is important for optimal performance. Ensuring proper layout. The layout of the components on the circuit board can also affect the performance of the circuit. It's important to ensure that the components are placed in the correct locations and that there is proper grounding and routing. Minimizing losses. The Joule Thief circuit can experience losses due to the resistance of the components or other factors. Minimizing losses can be done by using high-quality components, reducing the length of wiring, or using thicker wires. By taking these steps, it's possible to optimize the performance of a Joule Thief circuit and achieve better efficiency and performance.
Excellent insights. Now, on to the next point of discussion. If a Joule Thief circuit is not operating correctly, what troubleshooting steps can be taken?
Of course, to troubleshoot a Joule Thief circuit, you can take the following steps. Check the wiring. Make sure all the components are properly connected, and there are no loose connections or broken wires. Check the components. Make sure the components you are using are working correctly and are the correct values. Check the battery. Make sure the battery you are using is fully charged and has enough voltage to power the circuit. Check the LED. Make sure the LED is working correctly and is properly connected. Check the transistor. Make sure the transistor is working correctly and is the correct type for the circuit. Check the resistor. Make sure the resistor is the correct value and is not damaged. Check the coil. Make sure the coil is wound correctly and is the correct size and type for the circuit. Check the frequency. Use a frequency meter to measure the frequency of the circuit, and make sure it is within the expected range. Check the voltage. Use a multimeter to measure the voltage at various points in the circuit, and make sure it is within the expected range. By going through these steps, you can identify and fix any issues with the Joule Thief circuit, and ensure it is working correctly.
Brilliant explanation. Let's dive into our next inquiry. What's the maximum voltage capacity that a Joule Thief circuit can manage?
The maximum voltage that a Joule Thief circuit can handle depends on the specific components used in the circuit. Generally, the voltage rating of the transistor and the capacitors will determine the maximum voltage the circuit can handle. It's important to choose components that can handle the expected voltage to prevent damage or failure of the circuit. It's recommended to refer to the datasheets of the components to determine their maximum voltage ratings and to ensure they are suitable for the intended application.
Fantastic. Could you walk us through the efficiency of the Joule Thief circuit compared to other circuits?
With pleasure. The efficiency of a Joule Thief circuit can vary depending on the specific design and the application it is used for. However, in general, Joule Thief circuits are known for their high efficiency. One reason for this is that the Joule Thief circuit is designed to operate in the resonance mode, which allows it to achieve high voltage gains with a relatively low input voltage. This can result in a more efficient use of power and higher energy conversion efficiency. In addition, Joule Thief circuits can be designed with low power consumption and low component count, which can also contribute to their overall efficiency. Overall, the efficiency of a Joule Thief circuit can depend on various factors, such as the design, the components used, and the application it is used for. However, when designed and implemented properly, Joule Thief circuits can be highly efficient and effective for voltage-boosting applications.
In conclusion, we are delighted to have shared the artificial intelligence's perspective on the Joule Thief circuit in this video. We extend our gratitude to the AI for its insightful answers, and we promise many more engaging dialogues in upcoming videos about this fascinating Joule Thief electronic circuit. We are confident that these conversations will be genuinely amazing. If you enjoyed this video, we kindly invite you to subscribe to our channel and activate the notification bell to stay updated with all our new content. We also encourage you to share your thoughts in the comments section, and feel free to suggest topics that interest you. This way, we can continue exploring AI's opinions on various subjects. Thank you for watching. Until next time, stay happy and keep exploring the wonders of artificial intelligence. See you in the following video.